This is Brony Calc. This is pair 4 of the ARML 2017 individual round, numbers 7, and 8. And we'll be doing it in under 10 minutes, starting now. So, number 7 is actually one of the two I missed at the competition, but don't worry, I know how to do it. I know what I did wrong. I'm not going to make the same mistake again. So, we've got this long and complicated polynomial where we've got I plus 1 cubed I minus 2, is it I minus 2 or I plus? It's I minus 2 cubed plus 3 I plus 1 squared I plus 3 I minus 2 squared plus 3 I plus 1 I plus 3 squared I minus 2 plus I plus 1 cubed. So first off, you might be tempted to think that this is just, it's one of those binomial theorem, perfect cube things just expanded out. Except, if you'll notice, our first term would be I plus 1 I minus 2, and our second term would be I plus 3, until we get to here. But maybe we can fix that. Maybe if I do this, if I change this to an I plus 3 cubed and then add I plus 1 cubed and subtract I plus 3 cubed. Well, now we've got this. So we've got I plus 1, I minus 2, plus I plus 3 cubed. That's what all of this is, plus this. And we'll get back to that, but first let's focus on this. I plus 1, I minus 2. We've got negative 2, and then we've got negative I, because 1I, negative 2I, you get it. And then negative 1. So we've got negative I minus 3. But combine that with I plus 3, and this whole thing just becomes 0. So all we're really working with here is I plus 1 cubed minus I plus 3 cubed. Now, when I did this, I decided to break it down to difference of cubes factorization, and I got a lot more calculations, and I made an off by 1 error somewhere. So we're going to avoid that. We're just going to take this as it is. So let's start with I plus 1 cubed. We'll do I plus 1 squared first. I plus 1, I plus 1. 1 and negative 1 cancel, leaving 2I. Now, you might have that memorized, but I think it's helpful just to work that out. So 2I times I plus 1 is negative 2 plus 2I. So then we have I plus 3, I plus 3. You can see I'm master of writing anyways. So we got 9, negative 1, so 8, and then 6I. And then we want to multiply by 3 plus I. We get 24 minus 6 is 18. And then we get 3 times 6 is 18. And then 18 plus 8 is 26. So you've got this minus this. So negative 2 minus 18 is negative 20. 2I minus 26I is negative 24I. And that is the answer we're looking for. So I did it right this time. Yay me! And we finished in just under 4 minutes. So we have plenty of time to go into number 8, which is one of my favorite problems from the entire competition this year. You'll see why. So, got this triangle. Let me try it again. Right triangle. This is 17. We don't know what this is. B. And I'll get back to this point, but for now we got this right triangle. BC is 17, and C is right. And we know that we have some point E here where CAE equals EAB, so we have an angle bisector hitting BC at E. Going write those. And then we have the circumcircle of ABE hits AC at F. So, I'm going to write it this way. I'm going to say that we have some point F on AC such that AFEB is a right triangle. I'm going to draw this. Cyclic quad. Why did I say right triangle? This is a right triangle. AFEB is a cyclic quad. So, we can actually start playing around with stuff right away. Cyclic quad rules. We know that this angle is equal to this angle. So I'm going to move it over here. This angle is equal to this angle. So now we know that angle FEB and angle BFE are the same. So BEF is an isosceles triangle, which actually is really, really nice. So, continuing on, we know that CF is 3, and we are looking for AB. So let's start playing around with this stuff. I'm going to call this X, I'm going to call this Y. So, we have X and Y. X plus Y is 17. And then this is Y, so this is also Y because we found that this is isosceles. So we know Y squared minus X squared by Pythagorean theorem is 9. So I'm going to divide Y minus X is equal to 9 over 17. So we're already starting to step into some ugly stuff. But Y plus X is equal to 17. So 17 squared is 289, which means that 2Y, or just adding these together, 289, 298 over 17, which gives us 149 over 17 is Y, and X therefore must be 140 over 17. All right, 17. There we go. So, now that we know that, we can actually go to our angle bisector theorem. So we're going to call AC A, because why not? And this is going to be the square root of A squared plus 289. So, we've got A squared plus 289 over A squared. Note that, so basically what I'm doing here is we have square root of blah 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 over Y is A over X. So I can write this over this is Y over X, and then I can square it. So we have A squared plus 289 over A squared is equal to Y over X squared. But we know Y is 149 over 17, X is 140 over 17. So 149 over 140 squared. So, but this is just equal to 1 plus 289 over A squared. So I'm going to subtract 1 from both sides. 289 over A squared is equal to 149 squared minus 140 squared over 140 squared. So I'm going to write this as 17 squared. You're going to see why soon. We can use difference of squares. 149 plus 140 is 289, which is 17 squared, times 149 minus 140 is 9, 3 squared, 140 squared. So, if I flip this around, I can cancel this, take out all the squares. A has to be 140 over 3. But we have 140 over 3, 140 over 17, 149 over 17. So this must be 149 over 3 by the angle bisector theorem. And that is indeed the answer. So this problem is, honestly, if it's not my favorite problem from this competition, it's in the top 3, just because of how nice this cyclic quad trick makes the whole problem. Turns it into relatively simple Pythag bash. I know some people use PowerPoint, but they said that got really messy. There were other strategies that didn't work as well. So I really just like how it ended up. And, yep, we are still under the 10-minute mark. 4 for 4 so far are really nice. So, as usual, be sure to like, comment, subscribe. Tell me what I did wrong. Tell me what you liked about it. Share it with your friends. Hit the notification bell so you can see when the next one comes out, which will be soon. And I will see all of you there. Till then.